and very simple example we are having. Prove by the principle of mathematical induction that 1 plus 2 plus n times, that is equal to n times n plus 1 upon 2. So, how to start it? Now, just look, let Pn be the statement given by Pn is such that 1 plus 2 plus 3 plus n is equal to n times n plus 1 upon 2. Now, basic step, step 1. Basic step. Now, what it is? For n is equal to 1. P1 is equal to 1 and this is equal to 1 times 1 plus 1 upon 2 and this is equal to 1. Now, when I am putting 1 here, this means what? On the left hand side, as I told you, it is term, and on the right hand side it is the result. So, n is equal to 1 means what? First term, that is 1. So, that is why I have written 1 here. And this is the result, putting n is equal to 1, we are getting 1. Thus, P1 is true. Step 2. Induction step. For n is equal to k. Now, assume that Pk is true. Second step is, that is the induction, we are just proving, we are just assuming that Pk is true. Now, one plus 2 plus 3 plus k. Now, in place of n we are going to put k, plus k is equal to k times k plus 1 upon 2. Now, this is what? This is the induction step. Now, first step is always basic, second is the induction step. Now, step 3. For n is equal to k plus 1. We will prove that P k plus 1 is true. Now, this we are going to prove it now. To obtain P k plus 1, add k plus 1th term, that is k plus 1. In our question it is k plus 1. Okay. So, to obtain P k plus 1, add k plus 1th term. Just think it, this thing and these things both are different. This is k plus 1th term. Add k plus 1th term, that is k plus 1, to both sides of step 3. Now, what we are getting? 1 plus 2 plus 3 plus k plus 1 I mentioned here to both sides of step 2, not 3, for step 2 is equal to, here it is k plus 1 upon 2 plus k plus 1. I have added to both the sides. Now, 1 plus 2 plus 3 plus k plus 1. I am writing the last term is equal to k in the bracket k plus 1 times upon 2 positive of k plus 1. Now, right hand side becomes k plus 1 plus twice of k plus 1 divided by 2. Taking k plus 1 common, k plus 2 upon 2. Now, just look here, if in place of our third step was n is equal to k plus 1, now in place of n, if I am putting k plus 1, then this n is k plus 1 and this is k plus 1 plus 1, that is k plus 2 upon 2. Okay? Thus, p k plus 1 is true with the assumption that pk is true. Hence, by the principle of mathematical induction, Pn is true for all values of n where n belongs to natural number. So, this was all about how to go systematically for a question.